Hi Year 10, welcome back to our online learning. We're continuing down the algebra route. We're going to look at solving quadratics, which is something that we did towards the start of Year 10. And we're going to just re-go over it again. I'm going to start with the basics in this video. We're going to be looking at solving by factorising, thinking about all the different types of factorising that you need to be able to do, and then we're going to look at using the quadratic formula and also completing the square. This might seem in your head like something that you feel fairly confident with, but I do still strongly suggest watching the whole video and making some really thorough notes, because there are some types of quadratics that we didn't focus on so much, which are a little bit more complicated, which I am going to go into lots of detail in this video. Okay, so first thing is, when you see a quadratic, you might think it must look like this, but that is not always necessarily the case. This is also a quadratic. A quadratic is something that has an x squared in, and the x squared is the highest power of x in the expression. Okay? And when you think factorising a quadratic, you're usually going to think, does it need to go into double brackets? However, if we look at this example on the left, that has something which is common to all of the terms. So in this one, I'm not going to put it into double brackets. I'm going to bring an x out to the front, which is the common term, or the common factor, and then I'm going to factorise it like this. So don't always assume, as soon as you see the x squared, assume that it needs to go into double brackets. Sometimes it can just be factorised like you would a linear expression like this. This could be factorised by bringing a 4 out to the front, like that. Okay, a quadratic that looks something like this, if I go through each of the terms, there is not something that's common to all of the terms, and that is when we try and put them into double brackets. Okay, I'm going to model 4 very, very quick examples for you, and then I'm going to ask you to have a go at some of your own. So the first one says x squared plus 4x minus 5. Okay, the way that we factorise when it needs to go into double brackets is I draw my double brackets out. The first thing I consider is, how do I make this first term? With the easier type of examples we're looking at here, the only possible way I can multiply two things together to get x squared is having an x and an x. That's priority number 1, checking that position. Priority number 2 is checking this position. And don't forget, it's the negative symbol as well. In the one underneath, it will be the positive symbol as well. We need to think about what two things are going to multiply to give me negative 5. So I list out all the factors of negative 5. I can have 1 and negative 5. I can have negative 1 and 5, and that is it, because 5 is a prime number. Okay, now I need to go down this list. I need to think about how can I add them together to give positive 4. But if I have 1 and negative 5, that gets me negative 4, so it's not going to be that one. But negative 1 plus 5 does get me positive 4, so it's going to be negative 1 in that bracket and positive 5 in that bracket. The second one I do a little bit quicker. Same thing again, priority number 1, how do I make x squared? It's just going to be an x and an x. How do I make positive 35? Well, I know that it can either be 1 and 35 and 5 and 7, but I also know it could be negative 1 and negative 35 and negative 1 and negative 5, and negative 7. I have to check all of those. 1 plus 35 gives me 36, not that. 5 plus 7 gives me positive 12, not that. It must be this one. So it's x minus 5 and x minus 7. Next one down. I need to think about what gives me x squared, x times x, and what gives me positive 9. This time, to give me positive 9, it's going to be 1 and 9, 3 and 3, or negative 1, negative 9, negative 3, and negative 3. It's positive 6, so it must be with both the positive 3's. Or I could write this as x plus 3 squared. Same for this bottom one. If you notice, everything is the same here except the middle two terms. I've already listed out all the factors of 9, so this one I'm just going to write straight as x minus 3 squared. I can write that because it's x minus 3 multiplied by x minus 3, and I can just condense it down to give me x minus 3 squared. Okay, here are some for you to try. The first 4 should be nice and straightforward. There are 2 stretch questions. If you want to have a go, please pause the video and have a go now. The answers will be coming up shortly. Okay, the answers are now there. If you could please check them and mark your work. A special point, you can obviously have the brackets either way around, so z plus 9, z minus 6 would also be correct. The stretch If you think about this one here, for example, where I had a 7 in this position, I have a 14 in the middle, which has been doubled, which is called completed square form. We're going to come on to that a little bit later on. So where I've got minus 2a, this one here must be an a. And if I expanded this out properly, you would see that I get x squared minus a x minus ax plus a squared, which would give you that middle term there. This one, if you notice, everything has got a power of x to the power of 7 or above. So if I factorise an x to the power of 7 out, I'm left with x squared, because that multiplied together gives you x to the power of 9, x to the power of 8 from this one, and minus 2x to the power of 7, and then that can be factorised. That is really, really, really tricky. I've never seen anything quite so difficult on a GCSE exam, but if you are wanting to push yourself to those top grades, then it's definitely worth looking at. Okay, next style of question that you need to be able to answer is something where there isn't a common factor between them all, but there isn't 3 terms like normal. So on all of the examples that we've looked at so far, I've had an x squared plus an x term plus a number, but here I've only got the squared term and the number. I don't have the middle term. Okay, this is called difference of 2 squares. If you look at all of these, this is a squared term, 4 is squared, x is squared, 1 is a square number, 4 is a square number, x squared. All of these first 4 have got square factors. 16 is square, 9 is square, x squared, and 9y squared. They're all square terms, okay? So I think about what the first term is. What would I have to multiply together to give this one? It would be y. What would I have to multiply together to give 4? To give 16, sorry, it's a 4, and 1 is a positive and 1 is a negative. If I expand that out, that's going to give me the y squared, then I'm going to get a minus 4y. That's going to give me a plus 4y, and I know that if I've got minus 4y and plus 4y, that actually gives me 0y in the middle. So the reason that the number has to be the same in the second position, and 1 is a positive and 1 is a negative, is because it makes the y term or the x term in the middle disappear. Same thing on the one underneath. I know I've got double brackets again, and I know that it's a square number here and a square number here, so whatever is in this first position must be the same, and whatever is in the second position is the same, and 1 is a positive and 1 is a negative. Okay, looking at the second term, it's quite easy for me to spot. It's a plus 3 and a minus 3, but the first term is the bit that I need to be careful of. What do I multiply by itself to give me 4x squared? Okay, it's going to be 2x and 2x. Really important here, they have to stay in the correct corresponding position, so whatever is in position 1 here, so 4x squared, needs to be position 1 in the brackets. Same thing for the 9, the 3's has to be in the second position. Third one down, what squared is 1? Well, it's just 1. What squared is x squared? It's just x. This one, same process, looks more complicated, but actually it's the same as the ones we've just looked at above. What times itself gives you 4x squared? It's 2x and 2x. One's a plus and one's a negative. And then what multiplies by itself to give you 9y squared? It's 3y and 3y. Okay, one's at the bottom, 2x squared minus 8. That doesn't look like I've got square numbers there, but what I can see is I can see a common factor. So I'm going to go right back to the basics of factorising. Is there something I can take out which is common to both of them? There's a 2 as a factor of this one, and there's a 2 as a factor of this one. So the first thing I'm going to do is I'm going to factorise a 2 out. Okay, and that's going to leave with 2 brackets x squared minus 4. Now I've got x squared minus 4, I can see the difference of 2 squares, so I still need that 2 at the front, but now I'm going to have double brackets. What multiplies to give you x squared? It's x and x. What gives you 4? 2 and negative 2. This one I put in as a bit of a trick question. There is no common factor to 2x squared and 75, and so for that reason I can't factorise something first and then do difference of 2 squares. This one is a trick question, it can't be factorised. Okay, there are 8 questions for you to have a go at. Please pause the video and have a go, and then the answers will appear shortly. Okay, the answers are now there. Please can you mark them and check your answers. I think they start out quite nice and simple. Plus 6 and minus 6. 3x plus 1, 3x minus 1. It starts to get a little bit more tricky towards this end. But again, if you follow the same principles, everything there is a square number, so I can factorise it. The one underneath needs to have a factor taken out of 5 first, and then I've got difference of 2 squares. Take a factor out of 3, difference of 2 squares. Factor out of 6, then difference of 2 squares. Okay, the next type of factorising that I need to be able to do is what happens if the coefficient of x squared is not 1. Okay, and what I mean by that is coefficient is the number that's in front of x squared. So what happens if that number is not a 1? What happens if it's a different digit? Okay, I'm going to look at the first 3 examples where it's slightly easier. I'll then ask you to please pause the video and email me any questions you've got if you have some. And then we'll look at the 3 bottom ones, which are a little bit more tricky. Okay, so the first one says 2x squared plus x minus 3. And we said right at the beginning when we're factorising something that needs to go into double brackets, the first thing we need to think about is what would I multiply together to give 2x squared. Now before, when I had x squared, it was quite obvious that it was x and x, but now it's 2x squared. One of those must one of those must be a 2x and one of them must be an x. We then need to look in this position, position 3, and think about what numbers multiply to give me negative 3. It's either 1 and negative 3 or negative 1 and 3. Before I think about putting the symbols in, I can see that the fact that I've got a 2x here, whatever goes in this position is going to be affected by a factor of 2 as well. Okay, so I know that it needs to add to give me a 1 in the middle. So let's think about imagining I had a 3 here and a 1 here first of all. When I expanded that out, not taking signs into consideration, I'm going to get a 2x and a 3x. If one of those ends up being a negative, which I think it will be, is it possible for me to get a 1x? Yes, it is. Let's try it the other way round. Without thinking about any symbols in there, when I multiply this out, I'm going to get 2x squared plus 6, there's a 6x there, whether that's positive or negative I don't know yet, and a 1x. A 6x and a 1x is probably going to give me a 5 or a negative 5x, so I'm not going to go for this one. I'm going to go for this one here, 2x with a 3 in the same bracket and an x and a 1 in the same bracket. Again, it is trial and error, there isn't a quick way to do this. Now I need to think about the symbol. I need a positive 1x. So if I had a positive in here and a negative in here, I would end up with 2x and a negative 3x. That would give me negative 1x. So I'm not going to go for that one. I'm actually going to go for a positive in this bracket and a negative in that bracket. Obviously, you're not going to, on your page, scribble out or anything like that. I want you to try it out with a few different combinations of brackets. I'm going to do the same thing for the second one down, talk through the same process, but this time I'm going to do it exactly how I would do it in the real thing. Okay, so I can see that there's no common terms, so it must be double brackets, and I know that one of them must be a 2x and the other one must be an x. The reason that I have to have a 2x in one and an x in the other is that's the only way I can multiply to give 2x squared. Now I need to think about all the things that multiply together to give me positive 12. So positive 12, I'll list out all the factors. It's either 1 and 12, 2 and 6, 3 and 4, or the negative versions. Okay, I'm thinking by looking at the middle thing there, the fact that it's positive, it's probably going to be the positive versions, but I'm not too sure yet. Okay, now there's 3 different combinations that I can try here. I can either try the 1 and the 12, so that's what I'm going to do first. If I put the 12 in this box and the 1 in this box, then I would end up with 24x and an x. There's no way that that could multiply to give 11. Okay, so instead I'm going to try it the other way round. A 12 in that box and a 1 in this box. 2 times 1 is 2, and 12 times x is 12x, so that would give me 10x, so it's not going to be that one either. Okay, so I try out my next set of brackets. So I've ticked off that pair. Now I'm looking for the 2 and the 6, so let's try putting the 2 in one box and the 6 in the other. The 2 times the 6 would give me 12, and x times 2 would give me 10. X times 2 would give me 2x, but 12x and the 2x, I'm not going to be able to get 11x. Let's try it the other way around. 6 here and 2 here. The 2 and the 2 would give me 4x, and the x and the 6 would give me 6x. That would give me 10x again. Not possible to make 11. So let's try the third combination. That one didn't work, that one didn't work. So let's try 2x and x. Let's try the 3 in this bracket first and the 4 in this bracket. 2 times 4 gives me the 8, and 3 times 1 is 3. 8 plus 3 is 11. So that one would work. I can try it the other way around if I wanted to, just to prove that it doesn't work. The 2 times the 3 is 6, and 4 times 1 would give me 4. That would make 10, so that one's not going to work. So it has to be a 2x with a 3 in one bracket and the x with a 4 in another bracket. It's going to be both the positive ones because it makes 11x. It needs to be positive there. Okay, so as you can see, it's not particularly quick, it's not particularly nice, it's not particularly easy. The only way you're going to get better at these sorts of questions is by a lot of practice. This is one of the higher level skills of factorising. When we come on to video 2, when we're looking at quadratic formula and so on, you'll see that there are quicker ways of solving or factorising when you have a coefficient of x squared which is bigger than 1, but you might be able to do this on the non-calculated method. We're going to do one more example. Okay, so I've got 3x squared, and I know that that must come from 3x and x. That's the only way I can multiply two things together to give me 3x squared. Now I've got a 4 in this position, so I write out all the factors of 4. It's 1 and 4, 2 and 2, or -1, -4, and -2, -2. Looking at the middle there, it's a positive 8, so it's probably going to be the positive ones, but again, I ignore the symbols for now, and I just think about the numbers that could go in each position. I know I need to make an 8, so I know that working through my list, I need to think about, is it possible by adding and subtracting the numbers that I end up with that I could get an 8 there? If I put a 1 in this bracket and a 4 in this bracket, first of all, if I expanded that out, I would get 3x squared, I'd get a 12x and an x. There's no way that 12x and x is going to be added or subtracted to give me 8x, so it can't be that way round. So I try another combination. I swap them over. 3 times 1 is obviously 3. 4 times 1 is 4. 3x and 4x, that would make 7x, not 8x, so it can't be that way round. So I try the last combination. 3 times 2 gives me 6, x times 2 gives me 2, so 6x and 2x, that can make 8x. Again, because it's a positive 8x, I know that it must be the positive way around. So again, we put the numbers in the correct position first, and then we think about what symbols need to go in afterwards. If you have any questions at this point, please, please, please do stop and do ask me. Otherwise, I am going to continue with the slightly more tricky versions. 6x squared minus 7x minus 3, 4x squared minus 9x plus 2, and 6x squared minus 13x plus 6. If you feel like you're reaching your capacity in terms of finding this tricky, you can always skip ahead on these 3 questions. They are very, very, very difficult, but if you're willing to, please do persevere. So the reason that these ones are a little bit more tricky is because I've had a prime coefficient of x squared in all the first 3 examples, so it has to have been 2x and x, 2x and x, and 3x and x. Whereas 6x squared, there are lots of different ways that I could make 6. Okay, I could make 6 by having 6x in one bracket and x in another. I could make 6x by having 2x in one bracket and 3x in another, and then that's without me even having to think about what happens with this final term here. Okay, so I'm going to do it in lots of different ways. Let's start by having 6x in one bracket and x in another. So now I need to think about position 3. What do I multiply the numbers to get -3? So it's either 1 and -3 or -1 and 3. They're my combinations. So I'm going to test out a 1 in this bracket and a 3 in this bracket and see what happens. I'll swap them over, and if none of them work, then I'll move on to trying out this pairing here. So it's all a process of elimination. 6 times 3 gives me 18, 1 times x gives me 1, so 18 and 1x, there's no way I could make 7x by adding or subtracting. So let's try and swap them over. If I have a 1 in the second bracket and a 3 in the first bracket, let's try it. 6 lots of 1 is 6, and 3 lots of x is 3x, obviously, so that makes 9x or 3x if I was doing a subtraction. There's no way I could make 7x. So I've tried all the possible pairs with the 6x and the x, so I'm not going to use that combination. I'm going to try it with the 2x and the 3x. Okay, so let's try it with a 1 in the first bracket and a 3 in the second bracket. 2 times 3 gives me 6, 3 times 1 gives me 3, that makes 9, or 3 if I was subtracting. Doesn't work. So I try my next combination, swap the 3 and the 1 over, and let's see what happens. 2 lots of 1 is 2, 3 lots of 3 is 9. Can I make 7 from 9 and 2? Yes, I can, but 1 is going to have to be a positive and 1 is going to have to be a negative. But I already knew that from it being a -3 at the end there. So I know that one of them is going to give me a 9x and one of them is going to be a 2x, and I need to get -7x overall. The only way I can do that is by having a -9x and a positive 2x. So the 9x must be the negative and the 2x must be the positive. Please do pause that and re-go over that if that didn't make sense. I'm going to carry on with the next one. I've got 4x squared minus 9x plus 2. So I know to make 4x squared it's either going to be x and 4x or 2x and 2x. Okay, let's try the 4x and x first. Again, trial and error, seeing what we can do. Again, the question's fairly nice because the only way to make positive 2 is either 1 and 2 or -1 and -2. So I'm going to try out the 1 in this position first and the 2 in this position and see what happens. If it doesn't work, I'm going to swap the 1 and 2 over. If they don't work, then I'll try the second pairing of the x's. So what happens if I do 4x times 2? I get 8x. X times 1 gives me x. Well, 8x and 1x can give me -9x if they are both negative, which I know is possible. So I've actually managed to achieve it on my first go. If I decided to try this one out first, and I hadn't done this one first, I would still have got to the same answer by process of elimination. That would have given me 4x, that would have given me 2x, that would have made 6x or 2x using my subtraction and addition, so that one wouldn't have worked no matter which way round I had it. Okay, so this is my answer for this one. Final one, again for 6x squared, it's either going to be 6x and x, or it's going to be 2x and 3x. I'll try the 6 and the 1 first. How many ways can I make 6? This one's a little bit more tricky than the previous two because 6 is not a prime number, so there's lots of ways I can make 6. I can make it by doing 1 times 6, -1 times -6, 2 times 3, or -2 times -3. But this time there is 8 possibilities. There are 2 possibilities for the ways that I could have the first things, and also there are lots of possibilities for what I could have here. So this one's going to take me a little bit longer, a little bit more trial and error, but we will get there eventually. So my first pairing to try is 1 and 6. So I put them this way around. 6 times 6 is 36. 1 times 1 is just 1, so that would either be 35 or 37. That one's not going to work. Let's swap them over. Have it this way around. 6 times 1 is 6. 6 times 1 is 6. That makes either 12 or nothing, so that one can't work. So that pairing didn't work. Oh, I forgot to try the 2 and the 3. So 6x and x again. This time we're going to have 2 and 3 this way around. 6 times 3 is 18. 2 times 1 is 2. 18 and 2 is either going to make 20 or 16. Not the 13 I'm looking for. Swap them around. 6 times 2 is 12. 3 times 1 is 3. So 12 and 3x, 12x and 3x is either going to give me 15x or 9x. Doesn't work. Try my next pair. This time I'm going to have 2x and 3x in my first position. Again, I'm going to go back to the 1 and the 6 and see what happens. 2 times 6 is 12, 3 times 1 is 3, so it's either going to be 9 or 15. Doesn't work, let's swap them over. 2 times 1 is 2, 6 times 3 is 18, that's not going to work either. So it's actually my final pairing that I need to check here. So this time it's going to be a 2 in this box, a 3 in this box. 2 times 3, 6, 3 times 2 is 6, doesn't work, so let's swap them around. 2 times 2 is 4, 3 times 3 is 9, 4 and 9 do make 13. They both have to be negative. Negative 9 and negative 4 gives me negative 13, and that's going to come from the negative 2 and the negative 3. Thanks for watching. Final thing you need to do for this lesson today is have a go at factorising these 6 questions. I know they are very tricky. The first 3 are slightly easier. The 4, 5 and 6 are slightly more tricky. Please do have a go at least 1, 2 and 3 and then I'll be putting up the answers shortly. Okay, the answers are now there for you to check. You'll see that in the first 3 it was fairly straightforward. First one is nice and simple because they're all positive. It does get down to some really tricky maths down there at the bottom. Big well done if you got that right. That's all for today.